So, welcome to Introduction to Algebra 1. So obviously for these 5 weeks, we'll be talking about Algebra 1. This is a very extremely essential topic when it comes to math. Like algebra is the base. And so for our first class, we're just gonna start off. I'm gonna start off by talking about me. My name is Dani, and I am a rising freshman at the overlay school, also meaning I am going to ninth grade this fall. Henry, do you want to introduce yourself or something?
Yeah, sure. So I'm also a rising ninth grader. We go to the same school together. And yeah.
Yeah, cool. Nice. Okay. So our first class, we will be talking about exponents and real number properties. So first of all, we have to know what an exponent is. So an exponent, it, an exponent, oh my God. Please excuse me, I cannot work on one singular monitor. Okay. Um, so an exponent is the little number you see in the up right corner. It shows you how many times you have to multiply the base, which is the big number I. So as you can see here, the base is 4 and an exponent is 2. So you have to multiply 4 2 times. And sometimes when the exponent is 2, we will call it a square. And likewise here, the base, oh, oops, the base is 3 and the exponent is 3. So we will be multiplying 4 3 times. So I have some problems over here and I will give you guys 5 minutes to do these 5 questions. And if you guys have any questions, just message to Henry. Yeah. All right, so it's been 5 minutes. Now we will do these problems together. So, A for A, the base is 3. Oh my god. Please give me a second. So it will be 3 times 3, which will be 9. And we are multiplying 3 2 times because the exponent is 2. And for B, it will be 2 times 2 times 2 times 2 times 2. And to save you from the calculation, we know that this is equal to 25. And again, we are multiplying 2 by 5 times because the exponent is 5. Now, we will do 1 times 1 times 1 times 1 times 1 times 1, which will be equal to 1. So this is an interesting thing. You notice that no matter how many times we raise the exponent to, 1 to the nth power will always be 1. So that's an interesting fact. And now for D, we know that this will be 0.3 times 0.3, 0.3. And all of these numbers are tenths, so when we multiply 3 of them together, it would go to thousands, which will be 0.27. Okay, and for E, the exponent is 4, so we will be doing 1 times 3 times 1 times 3 times 1 over 3 times, so 1 over 3. Da, 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 da. And this will be equal to 1 over 81. So now the thing for these are, when you have a fraction raised to a, maybe I shouldn't use numbers. When you have a fraction raised to a certain degree, I mean not degree, exponent. Uh, for example, you have a over b to the nth. This is essentially equal to a to the nth power over b to the nth power. You are distributing the exponent to both the numerator and the denominator. So this is the exponent slide. And on to the next slide. So I am sure all of you guys have seen PEMDAS or whatever they call it, GEMS, I think nowadays. Essentially, this is the order of operations. So this applies to every single math problem that you will encounter in your math career. So the first thing you do when you see a math problem is you will solve the calculations within the parentheses first. So in this case, it will be 2 times 3 because 2 times 3 is within the brackets or parentheses. And next, because there's no more calculations needed inside the parentheses, we will move on to the next step, which is exponents. And we see here that it's 6 to the power of 2, or we can say 6 squared. That would turn into 36. And now that we see in this calculation, there's no multiplication or division, we will just skip onto the subtraction or addition, which in this case, we will be doing subtraction. So 36 minus 52 will be negative 16. All right. So we will now also talk about the properties of real numbers. So first up, we have the commutative property, which is essentially you will be moving the numbers around the symbol, okay? And the thing for commutative property is you do not use this for subtraction or division. It simply will not work because we can do an example. 2 minus 3, is it equal to 3 minus 2? We can see here that 2 minus 3 is negative 1 and 3 minus 2 is 1. So we can see here that these two are not equal. So you do not use this for subtraction. And as I said, you also do not use this for division, as seen here. Is 2 over 3 the same thing as 3 over 2? No, these two are completely different numbers. So we do not use the commutative property for subtraction or multiplication. Now we have the associative property. It's associative property is when you just want to tell yourself which part of the calculation do I want to do first. Like a plus b plus c. In this case, a plus b plus c with b plus c inside parentheses is the same thing as a plus b inside parentheses plus c. And the same thing for multiplication. So again, we do not use this for subtraction. Yeah, subtraction or division. Let's do an example. 4 minus 1 minus 3. Is it equal to 4 minus 1 minus 3? We know that from the previous slide that we do calculations within the parentheses first. So this will turn into 4 minus negative 2, which will be essentially 4 plus 2 because two minuses, oops, the minus, make a positive. So this will be equal to 6, while 4 minus 1 minus 3 will be 0. So is 0 equal to 4? No, no. And likewise, you do not use this for division. You can come up with your own example and see why it does not work. So next up we have the distributive property. This is one of the most important properties. So essentially how it works is you have numbers inside the parentheses and a number outside the parentheses. So the number immediately outside parentheses will be distributed onto each individual number within the within the parentheses. And the thing is when if the number or in this case the variable a is negative, you'll be distributing negative a onto both a and b, b and c. So this will be negative a times b plus c will be equal to negative a b minus a c. Okay. So the identity property, so this is pretty straightforward. The identity of the number shown here, if we have a, if it's adding or subtracting a 0, it would remain the same. It would remain the same number or variable. But here in multiplication, if you multiply times 1 or you divide 1, it would still be a. And remember that for addition, okay, I hate one computer. Okay, for addition, it only works if you're adding or subtracting 0. It does not work if you're adding 1. Like here in multiplication, you're multiplying 1. You can't add 1 and still have the same number. And inverse property is kind of the opposite of identity. So you'll I hate this. Okay, so a plus negative a, which is essentially a minus a, is equal to 0. That's pretty straightforward, right? And a times 1 over a is equal to 1 because the a cancels out because 1 is in the numerator and 1 is in the denominator. So now I have some problems for you guys to solve. I've put the pictures over here, so if you guys need a reference, you can just look at it. I will give you guys 5 minutes to do these problems, and again, if you have questions, just ask Henry. Yeah. All right, so it's been 5 minutes. We will now solve these problems. Um, okay, so here, okay. Oh my god, my pen's not working. There we go. Okay. So first, what is our first step? According to PEMDAS, we will be doing the stuff within the parentheses first. And because there's no exponents, our next step will be doing the multiplications. So here, we will be first doing 20 divided by 4. So now the equation turns into 3 equals 1, and 20 divided by 4 is 5 times 32 minus 9. And we see that there's another multiplication calculation we need to do. So which is 5 times 32, so it'll be 3 minus 1 times 5, oh, oops, not 5, times 160, that's a 6, minus 9. And we will now also be doing 160 minus 9 because it's still within the parentheses. So it'll be 3 minus 1 times, oops, 151. And when we multiply a number inside the parentheses, I'm sorry, but my sister just came back, and if you guys can hear, I'm sorry. So this is essentially equal to 3 minus 151, which will be negative 148. And the thing is, guys, if you ever see me doing a calculation, make sure to point out any possible calculation errors because I am doing this in my head, and the chance that I do something wrong is pretty big. But okay, now we move on to the second problem. So here we see that there's something within the parentheses, which is 5 plus 3. So we will be doing that first. So it will be 4 times 8 plus 3 over 3 times 2 minus 1. And now you see there's two multiplications, both in the numerator and in the denominators. Because they're not really affecting each other right now, we can do them at the same time. So right now it can be simplified to 32 plus 3 over 6 minus 1. So now our next step will be to simplify the numerator and the denominator, and then we can do the division. So the numerator will be 35, and the denominator will be 5. And so our final step will be to divide 35 by 5, which is equal to 7. Okay. Now the third problem. So this is a very lengthy one. And so first we do the stuff inside the parentheses, right? And you see there's two parentheses, no, 3. So we do the innermost one. That's so it'll be equal to 9 times 8 minus 5 parentheses, no parentheses, okay, whatever, minus 2 parentheses squared over, and we see here that there is an exponent, so we will also be doing that first. So it will be 16 divided by 16, which is 4 squared plus 2 times 4. Okay. So the next step will be to do that, to simplify the stuff within the parentheses, and in the denominator we will be solving this division. So it will be equal to 9 times 40 minus 2 over 1 plus 2. This is multiply. I'll just do next. Okay, 4. And like the other problems, we will just we'll just be following PEMDAS. So what is our next step in the numerator? It will be 38 squared. Oh wait, I just realized I've been doing something wrong the whole time. Okay. a second. I am so sorry about this, guys. I did not realize that it's 8 minus. Okay. It will be. Sorry, guys. I will be doing this in my head, and then we will get to the step that we were just on. All right. So now we have 9 times 1 squared over, oops, we will be doing the multiplication first, so it will be 1 plus 8. So our next step will be to do 1 to the second power, or 1 squared, which will be 1, because as we talked about earlier, 1 to the power of anything will still remain 1. So it will be 9 times 1 over 9, which will be equal to 1, because it will be 9 over 9. I'm very sorry about the earlier confusion. And so these are the answers. If you guys got the different answers, we can just check the steps and make sure you're not confusing the signs or do anything, because that is very common. So next, we will be doing variables and expressions. So this is essentially word problems, but we're also like bring letters into this, and letters in math is very fun. Okay, so first we have this equation, 9 plus 3 times, in parentheses, x plus 2, parentheses close, minus 5. So when x is equal to 4, we will be substituting x with 4. So this will be 9 plus 3 times 4 plus 2, close parentheses, minus 5. So we will be doing this together. This will be equal to do the parentheses first. 9 plus 3 times 6 minus 5, which would be equal to, oh, my handwriting. 9 plus 18 minus 5. And we'll be just doing this from the left to right, which will be 27 minus 5, which will be 22. So for this problem, we're just substituting the x with 4. So the next problem is actually pretty interesting. So when x is equal to 3, we substitute the x with 3. So for this one, it will be 3 squared, which is equal to 9. But for this one, there is a negative sign right here. And a negative sign, this is essentially equal to negative 1 times x squared. So these two are different. So we'll be substituting the x with 3. It will be negative 1 times 3 squared. So in this case, this will be negative 9. But for this, we see, for this one, we see that the negative x is within the parentheses and the exponent is outside. So first we have negative 3 squared. And we know that because two negatives make a positive, we will know that these two negative signs cancel out. So this will be equal to 9. So just notice how when a negative sign is in the parentheses, it's different from when it's outside. So when it's not within the parentheses. Okay, so now I have two more problems. I will give you all also 5 minutes again to do these. Alright, it's been 5 minutes. Now we will solve these problems. Let me get the pen. Okay. So when x is equal to 12 over 5, does 2x plus 3x plus 8 equal 20? So now let us just plug 12 over 5 to x. So this will be 2 times 12 over 5 plus 3 times 12 over 5 plus 8 equals 20. So that will be 24 over 5 plus 36 over 5 plus 8, 20. So now we can add these two together, which will be 60 over 5 plus 8 equals 20. And 60 over 5 can be simplified to 12. So does 12 plus 8 equals 20? Yes. So this is yes. So when r is equal to 4, is this equation correct? So now let us just plug 4 into r. It will be 3 times 4 squared minus 2 equals 46. So this will be 3 times 16 minus 2 equals 46. And 3 times 16 is 48. So does 48 minus 2 equals 46? Yes. So 46 is equal to 46. So this r is equal to 4. All right, so now we'll be simplifying equations. So first we look at this. We need to look at this expression. So the coefficients are basically the numbers in front of the variables. So the coefficients are always just the numbers, and the variables are always the unknown number. And a term is so a addition sign or a subtraction sign separates the terms. So the terms are always just multiplications or divisions, or just standalones. And a constant is a number by itself, because a number is constant. 9 is always 9. You can't change that. And so now we are going to look at like terms and unlike terms. You can combine like terms. And combining means you can add or subtract them. But you cannot add or subtract unlike terms. So what is a like term? A like term is when the variables are identical. So see here, t and t, they're the same. And x squared and x squared, they're the same. But in this case, y and t, they're not the same variable. So they're unlike. So that's an unlike term. And x squared, even though they're both x's, this one has a different exponent. And that's why it's a different term. It's considered a different term. And here, x times y to the 2 to the second power and xy, they're different because y is, for this one, y is raised to the power of 2, which is different from just y raised to the power of 1. And here, it's the same thing as the first one. W and x are not the same variable, so they are unlike. So now I have a few. We will be identifying the coefficients of these terms. All right, we will be doing them together. So, give me a sec. Okay, so what's the coefficient of 15 times p? Does anybody want to speak out? Or just, I can't see any raised hands, so just turn on your mic and just say. All right, nobody. Okay. So for this one, the coefficient will be 15 because 15 is the number part of this term. And for this one, the number part of this term is -7. And this one is equal to 5 over 3. times y. Oh, I'm not sure what my pen is doing. Which so so for here, the coefficient will be 5/3. I don't know what my pen is doing. And here, it might just seem like a negative sign, but the negative sign actually indicates -1. So this will be -1, A3, and B. So the coefficient here will be -1. And here, the same thing, the negative sign indicates -1. So this is actually -1/8 times x, and the coefficient is -1/8. Oh my god. Anyway, that says -1/8, but I don't know what my pen is freaking out about. Okay, now I have a few expressions, and as the directions say, I would like you to simplify by combining the like terms. So combining meaning you add or subtract them. Yeah, I'll give you 5 minutes. Alright, so it's been 5 minutes. We will now do these problems. Okay. So let me get the pen. Okay. So for A, um, these two are like terms because, oh my god, they have the same variables. And my pen is not working. Okay. So this will be 9m plus 5m. This will be equal to negative 4m because when you combine like terms, you are essentially doing the calculations with the coefficients. So it will be 9 negative 9 plus 5. And for this will be 6r plus 3r plus 2r. Because all of these are like terms, we'll be just adding them together, which will be 11r. Okay. And here, this is 4x plus x. The x is essentially 1x because from the identity my dad just used the microwave, so the Wi-Fi just evaporated. Just give me a quick second. Uh, there we go. Uh, and if you can hear my sister, I'm so sorry. Uh, okay. So here, I cannot. Let me get the pen. Okay. So 32y plus 10y squared. And here we notice that y and y squared, they're not like terms, so we cannot combine them. So this is already the simplified form. We can't simplify either, so we just keep it as 32y plus 10y squared because these two are not like terms. Okay, now I have additional problems. Same thing, we will be combining the like terms. But now there's just more operations that we need to go through. So again, I will give you guys 5 minutes to do these problems, and once you're done, just message Henry. Yeah, and if you have questions, also just ask, unmute your mic, or just put in the chat. Okay, again, it's been 5 minutes. We will do these problems now. So these pretty all have all the same logic. So we will be doing the stuff inside the parentheses first, and then move on to exponents, and then multiplication and division, and then subtraction and addition. So here it will be 14y plus 2. Oops. And as we learned earlier, we will be doing the distributive property. So we'll be distributing 2 onto 6 and 3y. So this will be 2 times 6, which is 12, and 2 times 3y, which will be 6y. And we see that there's 2 like terms, 14y and 6y, because y, they're like terms. So this will be 20y plus 12, and this cannot be simplified any farther because these two are not like terms. And then for this one will be 9k minus 6 minus distribute negative 3 onto 2, which will be negative 6, and negative 3 times negative 5k will be plus 15k. And there's 4 like terms actually. 9k and 15k are like terms, and negative 6 and negative 6, they're not really considered like terms. It's just that they're both constants. So yeah, this will be 20. But then that's not there. 24k minus 12. And a little side note, this is like math grammar-ish. We always order our terms by degree, and degree are the power that the exponents that these numbers have. So for this one, this is k to the first, and because this doesn't have any variables, it stays in the back. It's a constant. So we'll see more of this later. And for this one, this will be the same thing. This is actually negative 1. Distribute will be negative 2 plus r, because there's negative r plus 10r, which will be, although this is equal to plus 11r, we will just move it so it's more grammatically correct. So it will be 11r minus 2. And the thing is, when you're moving terms around, you always carry their signs with them. So here we carry the negative sign here. That's a little side note. And then here will be negative 2 over 3x, and this will be plus 4 minus 1 over 6x, and these two are like terms, so this can be turned into, oops, wait a sec. Oh my god, my brain. Okay, 5 over 6, negative 5 over 6x plus 4. Okay, so these are the answers. And I see that we are just on time, and just a little at 1 minute. If you guys are interested, I have this extra problem. Just for fun. And if any of you want to stay, Henry has a Kahoot that he has. So if you guys want to stay to play the Kahoot, that's totally fine. Yeah, Henry, do you want to share your screen for the Kahoot? Henry?
Yeah, I'm getting that
Okay,
done.
cool.
Can anyone see my? Oh, there we go.
Anybody else want a drink? We're just saying this is not competitive. I mean, it is competitive, but you're not gonna lose anything if you going. Yeah. It's just a friendly little check to see if you understood today's class.
It's just exponents and it's like 6 questions. So
Oh, yeah. And extra math never hurts, I guess.
I'm gonna start the Kahoot.
So that was the game, and I think all of you did great. For the class and for the game, you're free to go. Have a nice week. We will see you on Monday or Tuesday. I don't know. Um, Yingzhao, Yingzhao. I don't know, but class is over. You're free to go. Okay. Um, for next class, I think it will go much smoothly because just today my monitor broke, so I'm just working on. And when you share the PowerPoint, it just goes full screen, and it's just a hassle if I have to switch tabs and all that. So, yeah.